Morning all. As I discussed in the last lecture about the bus topology, there is the some resistance problem in the bus topology. Whenever any cable is there, and due to twist of the cable, there is the magnetic field is generated, and due to that voltage drop will take place, and due to that uh, resistance come in that picture, and the voltage drop, due to the voltage drop, signal strength is decreasing, and due to that the signal strength is decreasing. That's why the signal is not properly flow between the source and destination, because signal strength is low. So that's why the bus topology is not successful, backward topology is not successful. That's why the new device come in that picture, that is the box, and this box having the proper ports are there, yeah, like RJ45 port, it is very smoothly, and we are connecting cable to here, yeah, it is very smoothly, yeah, there is the no friction. So there is the no friction, so it's 100%, there is the no friction, so resistance is not there, and due to that is resistance is not there. So what happened, whenever the sender send any kind of, yeah, sender, let me draw this one, yeah, so the proper port I have connected here, yeah, means proper box is there, and whatever the signals plus 48 volt and minus 48 volt come in the analog side, in the cable side. So whatever the signal is going here, and there is the no drop, yeah, and no drop. So that's why the signal is no drop, because it's a smooth port. Yeah, there is the no friction. So it's 100% good. Yeah. And the we like whenever we go to for long range, and long means long walk or long distance by walking, so we generally always as per the human being capacity, means the anybody can tired and he is stuck over there. So in that case, the boosters are there, yeah, like you can take a Coca-Cola, or you can take a like a Bornvita. So these are the booster which is increase the energy. Similar like that, in the electronic market, to booster the signal strength, so there is the transistor come in that picture. I'm not aware you are which background, but the transistor is the one kind of method which is amplify the signal, which is amplify the signal, which is increase the signal strength. Yeah. So that is the amplifier is put it here, means they are means the engineers kept the amplifier here, and it is increase the signal strength, so that whenever the engineers not putting centralized transistor, it is putting in every port. The transistor is kept in every port, it is put, yeah, it is it is designed the transistor in every port. After that, whenever the signal is reaching to here, it is the signal strength will be amplified, and then signal strength is also amplified here, and after that when it will out, so signal strength is also amplified. Yeah? So it is one kind of booster which is increase the signal strength. So once the data passing this box, yeah, so signal strength will be increased. And the receiver, this is suppose receiver, this is the sender, this is the sender. So sender, this is my sender. Yeah. So sender send the plus 48 to minus 48 volt. Once it will reach to receiver, so the signal strength will not decrease. It will increase. It will increase definitely, because this device, this box, increase the amplitude of the I can say increase the amplitude of the signal strength. It will increase. So increase signal reach to the receiver, so receiver receive the proper signal. Yeah. So this box is like there is in backend design is based on the transistor. So that box in the beginning, it is an electronic device, yeah, and which is increase the signal strength, and there are multi repeaters are there. This amplifier is also called repeater. A repeater means it is boost the signal strength. So this is the booster, one kind of booster. So in the beginning, it is called the multi-port repeater, but after that, the name was changed. Yeah, after some time, because whenever all banks are in one place, so that is called the bank hub. Similar like that, if all cables are connected in one box, so that's why the name of that device, which is the electronic device, that is the hub. Hub. Yeah. So what is the hub? Yeah, what is the hub? Hub is the electronic device. Yeah, it is not networking device. Means anybody ask what is the hub? So you can say hub is the electronic device which is boost the signal strength. Yeah, which is used for the networking purpose. Yeah, which is used for the connecting the cables. Yeah, that is the hub. Yeah. So engineer design that, that is the, as I discussed the engineer name in my previous classes. So engineer design that hub, and it's amplify the signal strength. So whenever any PC want to communicate with the another PC, the signal strength never down, never down. Yeah, because it's a proper plug-in port. Yeah, and the other thing is that it is the problem is that with the hub, it is having the single collision domain, single collision, collision, single collision domain. It is having the single collision domain, and it is having the single broadcast domain, broadcast domain. It is having the single collision domain. It is having the single broadcast domain. What do you mean by that? It means that it is having the collision, means whatever the two PCs send the data at the same time. So hub does not avoid the collision, means in the hub, collision will take place. Collision will take place. Yeah, means collision is happening in the hub. Yeah, and single broadcast domain. What do you mean by single broadcast domain? Means one send the data and all are receive the same data. It means only broadcasting also take place. Yeah. So this is the disadvantage of the hub. But don't worry, it is avoid the one problem, whatever the problem with the bus topology, that is avoided by the hub. Yeah? So that is the good thing. But the two problems, single collision domain, single broadcast domain. So onwards classes, I'll explain, I will first avoid the single collision problem, and after that, I will avoid the single broadcast problem. Yeah. So right now, the two problems are with the hub. Yeah. That is the disadvantage of the hub. Yeah. And hub having the single collision domain, single broadcast domain, that is the problem with the hub. Yeah. So right now hub is no more in the network because the switch come in that picture. So I'll explain one by one. But before explaining the switch, I will also explain the one more thing, that is the uh, that is the bandwidth, and the other one is the delay, latency. Yeah. So why I'm explaining you? Because between the source and destination, cable come in that picture. So we need to understand the latency part, and we need to understand in the bandwidth part. So let me explain two parts first. Yeah. Let me explain that part. Yeah. So what is the latency? Yeah. What is the delay? Yeah. So what is the bandwidth? This kind of question come in your mind. Yeah. So before explaining the switch and bridge, I will explain you in the next class, but let me explain the what is the bandwidth. Yeah. So if I'm talking about the simple terminology, if I'm going to any road, so road width, yeah, road width is called the in technically width. Yeah. But in the network, that is called the bandwidth. I'll explain you why it is called the bandwidth. Yeah. And the second thing is that the length. What is the length? Length means transmission media length is called the length. Yeah. So here is my bandwidth come in that picture. What is the bandwidth? The transmission medium width is called the bandwidth. Width. Yeah, in shortcut B and W, that is called the BW. Yeah, BW means bandwidth. Yeah, width of the transmission medium is called the bandwidth. Why the band come in that picture? It is the frequency difference. Frequency difference means it is the two frequency difference that is called the bandwidth, but I'm not going in the depth in the telecommunication side. What is the bandwidth? But you can easily understand bandwidth means the channel width. Channel width, whatever the width of the channel, that is called the bandwidth. Yeah, and it's like whatever the road length is more, not length, width. Low road width is more, so it will carry it will means carry the more traffic, more cars, more bikes, more trucks. Yeah, similar like that, the width of the transmission medium is wide, means maximum. It will carry the major traffic, it will carry the good traffic. Yeah, and what is the length? Means the that is the bandwidth. Bandwidth means transmission medium width is called the bandwidth. And what is the delay? Yeah, delay or latency. Latency. What is the delay or latency? Suppose your source is here, your source PC is here. It is in, suppose, India. Yeah, and your destination in the US. Yeah, US. Yeah, the suppose it is the Facebook. Yeah, so somebody access the Facebook from India to US, so it is going via optical fiber or any cable. It is going, the traffic is going via any cable, so your traffic is traveling in the cable. So length of the cable, yeah, length of the cable, length length of the cable, that is called the delay or latency. Yeah, because the latency or delay is directly proportional to the length. Length of the transmission medium is called the delay or latency. Yeah? So if my transmission medium is length is maximum, so my delay will be maximum. If suppose I'm going to India, like Mumbai to US, so it will take more latency, it will take more delay, because between India to US, it's the distance is very high. If I'm going to India to Singapore, so Singapore nearby the India, so latency will be minimum. Yeah, so latency is directly proportional to the length, directly proportional to the length. Yeah, and minimum length, you will access the website very fast. Yeah? If somebody access any website like Facebook from US, so the latency is high, means the transmission medium length is high, so definitely it will get the more latency. The page will open very slow. If Facebook in the Singapore and somebody access from Indian people access the website from the Singapore, so the length of transmission medium length is very minimum, so latency will be get a very minimum, so page open very fast. Means the latency is directly proportional to the distance, directly proportional to the length of the transmission medium. So length and means delay and bandwidth, the two terminology. Yeah? And if I'm talking about the speed, yeah, speed, yeah. If I'm talking about the bandwidth versus speed, both are the same or both are the different. Yeah, both unit is beat per second, beat per second, beat per second. I'll explain you what is the beat per second. Both unit is beat per second. Yeah. So is there any difference between bandwidth and speed? Yeah. Yes. It having the difference. Yeah. Like suppose in the road, if suppose I'm going in the working hours from office, so I will take more time. Yeah. More time, because my speed will be slow. Yeah. If I'm going to office in the afternoon time or in the midnight, So I reach my office very quickly. Yeah, because my car speed is very high on that time, because there is no traffic. I can run my car very fast. But in the peak hours, my traffic means the maximum cars are there. So that's why my speed is automatically slow. So similar like that, the speed bandwidth is like a maximum capacity of the transmission medium. Means suppose I'm going to ISP and I will explain you what is the ISP, but right now you can understand ISP. ISP means any service provider. Yeah. So I'm going to ISP and I'm asking, give me the 4 Mbps. Mbps, that is the unit. I will also explain what is the Mbps. Yeah. But right now I'll ask for the 4 bandwidth, means give me the 4 Mbps bandwidth. Yeah. So it's a fix. It's fixed. Fixed means it's a maximum capacity. ISP doesn't allow above the 4 Mbps speed. Yeah. Means that is the maximum capacity. Maximum capacity. Yeah. And suppose in the during working hours, I'm accessing that website is very slow. I'm not getting 4 Mbps. On that time, I'm getting the 3 Mbps speed. Yeah. So when in other day, means in the midnight is also lot of congestion is there in traffic, but I'm taking the like afternoon time. I'm getting the good speed. Yeah. Otherwise, early morning I'm getting the good speed. So that is the good speed means 4 Mbps. 4 Mbps. In working hours, I'm getting 2 Mbps or 2 or 3 Mbps. So that is the speed is means that bandwidth is very. So that is called the speed. Speed means current bandwidth, current capacity. Yeah, current capacity is 3 or 2. Yeah, like if I'm going to gym and I push up, I push up like 100, maximum capacity is 100. After that, I cannot push. So that is my capacity, maximum capacity. So that is called the bandwidth. Yeah. But in today, I'm only push the 50. So that is the speed. Yeah. So speed means what is the current beat per second. What is the current beat per second? That is called the speed. And what is the maximum beat per second? That is called the bandwidth. Yeah. So there is the minor difference between bandwidth and speed. Uh, Speed means current time. What is the current time the you are getting the beat per second? Yeah, that is called the speed. And if suppose in the maximum you will get 4 Mbps. Yeah, above 4 Mbps, you cannot get the bandwidth, you cannot get bit per second. So that is called the bandwidth. Yeah. So bandwidth denote the maximum thing and speed denote the current thing. Current, current. I hope you can understand what is the speed, and what is the bandwidth. Yeah. So these 3 words come in your life whenever you come to the means you're right now joining the CCNA. So that word is come to in your day-to-day task. Yeah. The speed, bandwidth, and the delay. Yeah. So let me stop today class. Next lecture, I will explain you about the switch and bridge. Yeah. Thank you so much.